Hi everyone. In this video we will talk about predicting single displacement reactions. I was telling you earlier on that metals replace metals and non-metals replace non-metals. So when we write a chemical reaction, you have to see where the cation, anion, and anion is. We cannot put two cations or two anions together. So either you can understand it in terms of cations and anions, or you can understand it that metals would replace metals, non-metals will replace non-metals. But it is not that simple. You cannot replace any metal with any other metal. We have to talk about an activity series. So metals are placed in a list where you are told that which metal is most active. So if I have, let's say, you have this in your packet. Technically, it should be francium, cesium, rubidium, and lithium. So metals are more active in this series, okay? Because metals are more active as you go down the group. Let me explain it right here. Metals are more active as you go down the group. Non-metals are more active as you go up the group. So let's talk about reactivity, the trend of the reactivity. Metals are more active as you go down the group, and as you travel towards non-metals, we have non-metals on this side. So as I travel towards non-metal, the reactivity decreases. Okay, so any element that is sitting on this side is less active than the one before, which is less active than the one before. And metals are more active as you go down. So francium is the most active metal. On the other hand, on this side, you know, uh, except I'm not talking about noble gases. So after the noble gases, I have fluorine here, and fluorine is the most active non-metal. So for non-metals, the activity increases as you go up. Okay, it increases as you go up. So I will say that the two F's are most active elements on the periodic table. Okay, this is one easy way to remember this. Two F's are the most active elements on periodic table. On metal side, it is francium for metals, okay, and it is fluorine for non-metals. So fluorine is the most active element for non-metals. That means non-metals are more active as you go this way and as you go up. Okay, if yeah, francium is most active element as metals, that means metals are more active down and they're more active going towards francium. So this is a general trend you need to know. And keeping that trend in mind, I can only replace the more active metal than the one before. So if I have sodium chloride and I react it with lithium, let's say I want to react it with lithium. Let's say I gave you the activity series on the back page. I have to see where is lithium on the periodic table on this series. Lithium is sitting below sodium. Okay, sodium is more active than lithium. If sodium is more active than lithium, then lithium will not be able to kick sodium out. So this reaction will not happen because lithium, according to my series, is less active. So I will say no reaction. Okay. On the other hand, if this was the other way around, if I had lithium chloride and I was reacting it with sodium, I check it with the series. Okay. Sodium is sitting above lithium. That means sodium is more active than lithium. So this reaction will happen. Okay, so this reaction will happen and I can have sodium chloride. So sodium can replace lithium. So lithium is kicked out right here and sodium makes a bond with chlorine. The other thing you need to know is that we cannot just, we're not playing blocks here where you can just take one off and put the other one in. So let's say I had MgCl2, and I reacted it with sodium. So sodium is more active than magnesium. So if sodium is more active than magnesium, then I cannot just say that magnesium goes here and I have NaCl2. Okay, this is a wrong equation. When you are combining them, like you want to put sodium and chlorine together, okay, you have to redo their formulas. So you need to know that sodium is +1, Cl is -1. So the formula should be NaCl, not NaCl2. Okay, so keep that in mind. That when we are redoing the formulas, we have to recalculate their charges. All right, so in this video, we talked about predicting single displacement reactions, and I told you we have to check with the activity series before you decide whether the reaction will happen or not. Let's talk about double displacement reactions. How do you predict the products on the double displacement reaction? So what happens is that you have the formula, you have the equation that aluminum iodide and mercury 2 chloride, and then there is nothing on the other end. Okay, so let's do this. So you have aluminum iodide, and mercury 2 chloride. So the question on the test is that there is nothing on the product side. So you have to predict the product. Well, to predict the product, I told you the easiest way for double displacement reaction is that you have to see which one is a cation, which one is an anion. We know that the first one is always a cation, the second one is always the anion. So if this is a cation, the ide part is the anion, then I have cation and the anion. So cation of this will bond with the anion of the other side. So my product will be aluminum chloride, and this cation will bond with this anion, and I will have mercury 2 iodide. Okay, so let's do another example. If I have Na2O plus AlCl3 and there is nothing on the other side, you have to predict the product. You have to see that this is the cation, anion, cation. So this cation will bond with this anion, and this one will bond with this anion. So again, as I was explaining earlier, that you cannot just take it off here and plug it in. I mean, you cannot just say that it will be Na2Cl3 plus ALO. These are wrong products, because you have to see if you want sodium and chlorine together. Sodium is +1, chlorine is -1. So the formula should be NaCl. And then aluminum is +3 and oxygen is -2. Okay, I want to bond these two together. Aluminum +3, oxygen -2. So the formula will be Al2O3. Okay, so these will not be the formulas. The formulas will be these. So you have to recalculate the formulas. Okay, so we're not done doing the formulas in unit 3. We're doing the same thing in unit 4 again. So the right equation will be NaCl plus Al2O3. And of course, this equation is not balanced. So your next step is to go ahead and balance the equation. Okay, we can go ahead and balance the equation later on. So this is how you will learn how to predict products for single and double displacement reactions. The rest we will practice in class. Thank you.